Did you went to Cancun after Guatemala, right?
Yeah.
Yeah.
Hey, Jonathan's here. I was like, oh, I wonder who's going to be on Zoom. And, there he is in real life.
For real? Oh, you keep going home. From going to your home. That's a dangerous place for you.
Excuse me,
Sorry, I have my conclusion. Your home is dangerous for you.
I'm killing myself. All right, so continuing on with 11 and 13, we started with 11. So you got 11 and 13 to knock out this weekend. Sorry, 10 and 11. Technically 13, but 13 doesn't have any problems of the apply problems, so it's really just the two.
Reading 10 doesn't have the apply problems?
No, I think it's 13 if I remember right. Check the Blackboard. I commented on there that there's no apply problem. There's like only review with one.
Oh, there isn't any for 13.
For 10?
Never mind, there is some for 10.
Okay, I thought there, yeah. Well, we did one of them. Yeah, that's what was the problem we were working on yesterday. The Gandhi stuff was 10.
I was thinking of 9, that's what it was.
But chapter 13 does not have any apply type problems. All right, so let's just kind of pick up here to review. Well, let's see. I was going to go one more back just to kind of refresh your memory. We talked about, let me just go to the very beginning. So office space and how much are people willing to pay for rent? Why are rents so high in the middle of the business district? And so kind of the one thing that this chapter hangs its hat on is that face-to-face communication is important in some industries, right? More so than manufacturing, let's say, or other things. So you've got two professional people, maybe it's an architect and an accountant, or it's an attorney and a real estate agent or something. And so having interactions face-to-face with the CEO and the manager and other people is an important way to communicate. And of course that's changed over the years. We're seeing some of the reasons we used to do it because of innovation, like with Zoom and other things, go away. But that is one of the reasons we see such a dense population and people willing to pay more money to be located downtown. So that's in large part what we're exploring here. And so kind of the median theory of how many trips do I have to take depending on my distance. They start measuring in terms of the distance from the central business district. So we have some companies located right in the middle, and then the further you get away, the more trips you're making to that increase the cost of doing business. Okay, so this is where we left off yesterday, I think it was. Modeling in that travel cost with distance and blocks, we can use the leftover principle and start to see that stuff that's close to the center, we're going to be willing to pay more money per acre for. All right, so where do we go from there? Any questions or comments before I move on? This is where we left off yesterday. Well, maybe not. Or did we? Yeah. Did we do this one too? Kind of feel like we did. No, we didn't. That's right. We left off with this one. So the land bid rent function actually has a real curve to it. So that's not necessarily a straight line, given those non-linear relationships between the travel expenses. So again, bid rent, as opposed to a real demand curve, we're not measuring quantity of product here, we're measuring distance from the center. So similar to some of our other stuff, here we're measuring dollars just like before, but now the distance puts us at a higher price of what we're willing to pay for it. All right, so what if capital improvements in land could now be substituted? What would happen to our buildings? So capital improvements, it would be something like building height, right? So could we make our buildings taller, spend more money on materials and the land? So what would happen then? What's the trade-off between land and building size? What's the trade-off? Is buildings getting bigger and you need more land to do that?
No.
Just the trade-off is buildings are getting bigger and land
It's getting more expensive.
getting more expensive, but what about the amount of land we need here?
It's staying the
Well,
same.
it's smaller.
It's less, is the trade-off that we're going to have. So, and it's interrelated with it becoming more expensive, but I can take, let me get my real estate developer hat on here. If I have 1,000 square foot space, I can get 3,000 square foot, 1, 2, 3, and maybe that 1,000 square feet sits on a piece of land that is, let me see if I can do this, I'm butchering it already, but there's my lot. And we need a 10,000 square foot lot to build 1,000. So now, what happens if I conceptually build a 500 square foot and go up high? I can still end up at 1, 2, 3, 4, 5, 6, I guess is all I'm trying to do here to double it conceptually. So now I've got the same amount of square feet, right? So this is 500 times 6 is 3,000 square foot total, which is what this was too. 1, 2, 3,000 is 3,000 square foot total. But now that I only have a 500 square foot footprint, I could use some amount of less square feet, right? So as my building size shrinks and I go vertical, then I would use up less lot size. So that's the trade-off here. What if capital improvements going vertical could now be substituted with less land? What would happen to our buildings? And so the idea here is if land gets smaller, buildings can get bigger. But it doesn't come without a cost. What is a vertical transportation system? Elevator, right, to go up and down. So back when I was developing apartment buildings, depending on the size, but you were looking at about 10,000 per floor. We built 9-story buildings, so it was 90,000 for just one elevator, which might not sound a lot to you, but if you're building, compared to an apartment building that's 3-story, that's all stairs and no elevator at all of a sudden it's an extra $90,000. That can get up there, and then you need, depending on the size of the building, you might need 2 elevators, so then it's $180,000 with that type of need. Reinforcements for weight bearing. What do you think that one is? Jonathan?
Like as your building gets taller, you have to switch from wood to steel or something?
It can be for wood to steel, yeah, that's part of the engineering that goes on. What about the foundation for weight bearing? So that would be one of them, wood to steel. What do you got to do?
It's more expensive because it must be
First floor.
better.
Better foundation, more concrete in the ground. So compared to this little guy here where you're spreading the weight out, you might be able to drill down, with 4 piers to support this thing. When we start going vertical like this, we might have to go deeper and ultimately hit bedrock and have that. So you're spending more on concrete, more on other things to build a proper foundation to hold that up. In addition to then you get into how much the wind is going to swing it. And so then you have to beef up some of the vertical strength. It's crazy how additional expenses go up to going vertical. It's not just, why don't we do a 5-story building instead of a 3-story building? And then all of a sudden these costs start kicking in and it can get pretty expensive. So here the author has some numbers to think about that I took from some real world data. So we have a tall, medium, and short building. And the number of floors, a 25-story building, a 4-story building, a 1-story, just a simple 1-story shop. And how much land is needed for each one. So you can put this on 0.04 of an acre, and this you need 1 acre. So he's kind of thinking about these trade-offs and what the capital cost is. And so in order to build these number of floors, which he's taking the amount and just keeping it equal in this case, kind of like what I was doing over there. So you have a $250 building versus the 100 versus the 50 in terms of the building cost. And so not all of you have had intermediate class, but we talk about ISO Quants. And we're not going to hit this very heavy, so even if you've never heard of that, or you don't remember, like if I quiz the people who have had ISO Quants, that might be even more interesting. What an ISO Quant was. Let me throw it out to you, upper division people who had ISO Quants in the previous class. Anybody want to take a stab at what an ISO Quant was, Lawson?
Is it just a linear function with a bunch of different slopes mapped out?
There's different slopes, I'll give you that, but that's not the best way to think of what an ISO Quant. So think of the ISO and then the quant. What does that mean? So this is an ISO Quant right here. ISO Quant. Bryce?
You have to be like, you're isolating certain quantities for a certain, like this would be like land or something.
Okay, so the ISO in general means same. I think it's Latin if I remember right. So you have the ISO lines, like when you look at a weather map, it's everywhere where it's 30 degrees and then it's 20 degrees when you guys look at the weather, right? You can see it go down to Texas and over to Florida or whatever. So along that line, the temperature remains the same. With an isoquant along this line, something's remaining the same. And in this case, we've got this trade-off here of capital costs, the dollars going up, and the lot size. So for that 1-story building, or for the 1-unit lot, I guess it was, for the lot size, we had a capital expenditure of a 50 for the building, for the small 1-story building. But then as we cut this in half, it wasn't a linear relationship to get up to, when we doubled it from 50 to 100, we were able to cut our lot size. And then when we go to the 25-story building, holding that constant, we've got it at 250. So the isoquant for 1 hectare of office space. All right. So not a big deal. We're just kind of thinking about how quickly the numbers change and how expensive it gets. So what is the options and optimal building heights? What is the best size? What is the size at best? What size is best at various lands rents? So we've got the tall, medium, short. And we've got the land. This is just replicating what we did before. And this was the cost. So now we're dealing with land cost and building rent. So if we had building rent of 40, if it was cheap, then that amount per spending the 250 It's like per square foot, right? Or it's like, you can think of it as $250 per square foot pricing. Then our total cost ends up being the fraction of the land rent. 0.04 times 40 is 1.6. And so our total cost is $250 when rents are cheap. If we come down here to the medium-sized building, the cost is $110. With the small building, when rents are cheap, then it's better to build a short one-story building. So if we're building on Ottawa farm ground that is relatively inexpensive ground, then you're better off just building a one-story building. Probably be in wood, stick frame, and whatever, because we've got the $40 worth of the land rent. So 1 acre is 40. So 40 plus 50 equals 90. And so what's the cost minimizing thing to do when rents are at 40? To build a short building. What if rents go up to 200? So moving a little more metropolitan. So at 200 for the tall building, it still would be 258. So 0.04 of it, we only need 0.04 of an acre, even at 200, so it'd be 8, but the building is really expensive. Here, with the medium size, we get the 0.25 of 200 is 50, and then 50 plus the 100 of the building cost gives us 150. And then look at what happened with the short building. When the rent got up, then it was pretty expensive to buy that big piece of land and put up the one-story building, so it was 250. So which one minimizes cost, tall, medium, or short? Which one is the minimizing cost? So if you're tracking along with me, we got total cost of the project. Which one is it, tall, medium, or short? Medium. So the medium one all of a sudden made sense because of the relationship between the land cost and the building cost. So those are the things that are trading. This is shrinking, but this is getting more expensive relative to the short building. And then finally, when would we ever find it profitable to build a 250 square foot per square foot, $250 per square foot building, which is astronomical compared to 50, right? 5 times the expense. For 1,000 square foot, you're spending 5 times the amount of money because of the elevator and the beefed up foundation and all of that stuff. Well, if land rent is $1,600 and you only need a postage stamp, then relatively speaking, that's not too bad at 64 of land cost plus the 250 for the building is 314 versus 500 versus 1650. If land rent is high. Okay, now I just kind of don't expect you to absorb all of that right away, but any questions? See the trade-offs that are going on between the building capital cost and the land cost. All right. What if we're allowed to substitute? So before, we didn't allow there to be a trade-off of building and land. It was a fixed relationship. So now we're going to mix that a little bit. So if we add in travel cost into this, it kind of makes it a little bit richer discussion. So the bid rent per acre is the willingness to pay, which is our leftover principal, divided by the size of the site of the acres. So this is the 1 block from the center versus 5 blocks from the center. So building height, if we're right in the middle, at 510 of revenue, we're going to hold revenue constant. Should we be in the big building or the small building? And what is the willingness to pay? So this is where the big advantage is with the travel cost at 46. Total rent paid, production site, remember we had such a small land cost here at 0.04, and so now we can afford to pay that kind of money. Why? Because the travel cost was offsetting that. So here's our two. Oh, looks like you guys get extra credit. I forgot to silence my phone. All right, pull out a piece of paper. Get this out of the way. Make sure we don't forget about it.
Yeah, it was only good.
Rust busted.
I had pulled it up.
It doesn't have to be great.
It's got.
Too bad.
All right, pass them in. 10 seconds. Get this going. Way to earn some free points. All right, so up on the screen then, this kind of highlights the with and without the substitution. So the top panel is what we started off with. What is different between the top and the bottom? Let's just look at the numbers. What's different between the top and the bottom?
I mean, we don't.
Building height set on the top one.
Okay, so building height is set here versus building height being able to change here with factor substitution. What else? What else was fixed up top? Capital cost. All of that was the same. Now that was the other non-land cost was the same here, right? So capital cost was changing with substitution.
Production site.
The production site. So we're not, what the point is here, we were not allowing there to be a substitution between building height, size, capital cost, and the production site. But when we allow the trade-off to occur, then we get this difference. And so it allows us the ability to pay a lot more with that plus the travel cost. The travel cost thing was going on before up here, right? That was the first thing we introduced that we're going back and forth. So that's still happening in the same way, going from 1 to 5. Well, what does that mean from the bid rent function? Is that it's steeper. So we can pay a lot more money for the site and for the building with the factor substitution. So now this is telling you why the downtown central area has the really tall buildings, the really expensive buildings, is that we have the ability to get a lot more out of them. So is this more or less elastic with factor substitution?
Less.
Less. Why do you say that?
Because I always remember that. Yeah, the inelastic is the I.
Okay, Carlos?
Is these flatter?
Because it's flatter. This one, so more or less elastic with factor substitution. With factor substitution is this one.
Pause and then.
So we start here with being 5 blocks from the center. And so the steeper one is width. So is that more or less elastic with factor substitution?
Less.
Less. So we've got a steeper curve and more willingness to pay, right? As we get closer with factor substitution. All right, so why is that? So suppose that we move from here, point E, where they were saying that that's kind of our starting place, 5 blocks away, and then we get closer with and without. What is going to drive the big change? So what I mean by dissecting it is we can break it into 2 pieces. So the first piece is the travel cost from point E to A. So remember, without factor substitution, we were holding the building site constant and the capital cost constant. That caused us to get this incremental bump here of the 656. So I could up my bid by 656 bucks because of my people having face-to-face interactions and their increase in productivity, right? So that was the benefit of having less trips if face-to-face interaction was important. And then what is the savings from factor substitution? You can think of going from A to J. And so now I've dissected parts of that so that we've got the building size now is what's really going from A to J, which is another 744 bucks. Okay. Questions or comments there?
They're saving money going from A to J?
Well, what they're really doing is going from E to J, but what we're doing is dissecting the parts. So if we just started here and we said, oh, if you go work in the central business district, you can afford to pay $1,600. Well, why? Well, my people have a lot of face-to-face, and there's that going on, and then also there's substitution of building and land going on. Well, all I've done here is dissected it, and I've said how much at the margin is attributable to the travel cost. Well, that would be going from E to A. That covers the travel cost part. Then that's the same whether you're in a tall building or how much you're paying for it. That's the advantage. And then the rest is the factor substitution effect. Okay. All right. Skyscrapers. We start thinking marginal analysis. How much does an additional floor cost me? What are the benefits of an additional floor? It's a normal profit maximization problem. Now, can you think of other advantages to the building being the tallest? Think about some of the cities, either in the United States or maybe Colombia. You've got some examples or something too. You know, what comes to mind in big cities? New York City, like, you know, what sort of things are going on?
Don't they usually like rent out the top floor for tourists?
Okay. So yeah, if you're the tallest, there could be some additional benefits to it that way. Maybe with tourists or something. Okay. Maybe a little bragging rights. I've got the biggest building, and because I had those bragging rights in Ames, so they do kind of feel good. I built the tallest building in Ames, along with my partners, who I was, by the way, a very small, tiny investor, but I got a lot of outside money. And so that's kind of nice, having that little feather in your cap. So, but would it always work out to be the optimal for society? So here's the idea of maximizing profit. Marginal cost, marginal benefit, and there's going to be an optimal building height. So at this height of 50 floors, profit is maximized at 900. Just using the numbers, you know, making up some numbers here. This is just from the author, of course. But so, what if it gets a bit taller? We start to lose money. Right? So it'll start to become not as profitable. Why? Because the marginal cost is exceeding the marginal benefit of an additional floor. However, what if you do have this outside benefit of I've got the tallest building, and maybe it attracts more tourists or gets more advertising when they show a picture of the skyline of the city, your building is the one that catches the eye because it's the highest on the skyline, whatever. So let's just assume that there's a $200 value if you have the tallest building. What should firm one do? So let's put kind of a game theory hat on, which is kind of similar to maybe what we were thinking about before on multiple people thinking about how much they should, how tall they should build the building. It's a sequential game. It's a sequential game. What does it mean to be a sequential game? Back to game theory,
One
kind of
person
101.
plays after the other
One person plays, then the other person plays, right? So they get to observe what one did. So knowing that two people are going to play a game, let's just boil it down to two people, there could be more. What should firm one do knowing that there's a $200 prize? What do you think? Lawson, I think I saw first.
Build 51 floors.
51, okay. Jonathan, what do you think?
I think they should just do the profit maximizing at 50, since everybody else is gonna see what they did, probably go higher and lose money.
Okay, so let's go through both of yours real quickly, and then we'll say. So if player 1 does 51, what does player 2 do?
They go 52.
Why do they go
That's
52?
100.
Because it's profitable to do so, right?
I don't think you should.
So remember,
I got it.
the winner has the $200 value if you do it. So if you do 50, if you're the first mover, because it won't move, then the other player is going to go higher. And then again, if we leave it a two-player game and it's a one-shot, then that would be it, which we could do. Jonathan.
Change my answer to 80.
Okay, change your answer to 80. Why 80?
Because if there's no point in them trying to top you, because if they top you, then they still lose money.
Okay. So at 80, the profits from the building itself is 700, but you've got the prize. So it's really 700 plus 200 gives you 900. And then the question is, well, wouldn't the next player pick 81?
No.
And the answer is no, assuming profit maximization. That's going to give you profits less than a 50 floor building. So the Nash equilibrium in a two-player, one-shot sequential game would be 80 and 50 if there's some sort of prize. The first would have incentive, having the first mover advantage would choose 80, and then the second developer would choose 50. And so we end up having floor heights that are pretty different from just being one story apart, depending on how big the prize is. All right, questions or comments there? All right, so this kind of walks us through what we just did, so I won't spend too much time on it here. So we got the 900, build the 51. What would firm 2 do? Well, they'd go 52. So what's the Nash equilibrium? You guys noodled it out here. Good job, Jonathan. You took the lead on that one. So what do we get for implications? So that's what we see in real cities, is that there is a gap between the tallest and the second tallest. And so was it a good idea? Well, for the two owners, if you think about the profits that they would have done, if it was 51 and 50, they'd be, one person would get the prize, the other one would basically be at 900. So the joint profits would be 2,000. But by being competitive with each other, the joint profits again end up being a little less at 1,800. And so it's kind of a prisoner's dilemma type of thing that, oh, we could have negotiated, like, let's have a contract so that we both make more money and divvy up the spoils. Like, we could kind of split this. Well, I know you're 51 stories and you're 50, but whatever. There'd be some sort of negotiable thing there, but instead we get to the prisoner's dilemma type of outcome of 80-50. Okay, questions are there? Okay, so Bryce and Jacob got to ask you, what are you so enthralled with on your machines? I haven't seen your eyeballs come up to listen to what I'm doing.
I'm gonna build mods
The mods on what?
on the
Okay. Other homework. Ouch. All right. So that's plus a minus. So remember, if you're going to use a laptop, you need to stay engaged here. I thought your eyeballs were down just a little too long. And so anyway, just for reminders for everybody, your laptops are to be note-taking devices, so even looking at the modules and other things is not what I'd like you to be engaged with. So McKenna, I guess I could fairly ask you to, I didn't see your eyeballs glued as much as their eyeballs were. What's that? Okay. All right. So, office space, so I think we're basically actually done with this. This is all kind of a repeat. There is a couple cool graphs here. Towards the end. Okay, let me just say too, I do not ask questions on this. So this, if you see the graph like this where they talk about this, I'm not putting that on the test or any of the questions. So there's some questions I told you to skip when you do the odd numbered ones, and it has to do with ISO quants and profit maximization. So that's what there's just a little section, one question that covers it, so one or two. So I put in the homework that you can skip those questions, that it's not relevant. So take note of that. Okay, this is kind of some of the fun maps to put up. So the spatial distribution of office activity, density of finance and insurance employment. So this is not a picture of tall buildings in Boston. It's a graph, like we do a two-dimensional graph, but what's extruded here is the amount of office activity going on in that area. So it kind of shows the cluster and how much activity is going. And you can pretty much bet your bottom dollar that if we did put a real picture of the skyline, there'd be tall buildings here too. But that's not what that picture actually is. And then I think there was one more here. Okay, just wanted to show a couple other different areas. So the spatial distribution of office again. So we got Atlanta, Boston, Chicago, Denver, Houston, Miami. The density at the center, the subcenter, and then outside. And so within these, we get kind of the same pattern that we get the higher density towards the middle. So it kind of supports the idea of face-to-face interaction, all the stuff that we do. The real world is coming up with that conclusion as well. Yeah?
I was wondering, what's 13 metros?
There's 13 of these here, I think. I didn't count them, but I think this is the 13 metros. And if you averaged them all, that would be the results. Okay, let's do a problem. See how we're doing. Okay, so let's do,
Watch yellow videos.
now let's do number 2. So if you have your book. Oops, but stairs versus elevator. So each firm in an office building occupies one floor of space, earns total revenue of $380, and incurs a labor cost of $300. Define H as the height or the floor level of the building. Intra-building travel cost is 10H per floor for travel by stairs versus C of H, CE for the elevator, 27 plus H for travel by elevator. Illustrate the willingness to pay for office space for the two travel modes for H equals 1 to H equals 53. What sort of firms use the stairs?
That's the formula is CS.
For stairs. So this is the intra-building travel cost function. So by traveling by stairs, it's 10 times H. Traveling by elevator is 27 plus H. So if you only have one story to go, how much does this run? 10. And how much does this run? 28.
Oh, 8.
You got the 1. So that's the idea. Kind of think about those trade-offs with the travel. gonna do B yet. Crazy.
Good guess.
So did you draw a picture for A?
Nope. I thought it was
I don't know how
common
to
sense.
I like numbers, but I don't know.
Might be something to draw a picture for.
We like the.
Yeah.
The equations made it really easy. So.
Yes.
I'm also really bad at drawing pictures, so.
Cost.
Yeah, this one's a little bit different because we're just bringing in height of elevators. So you could put, I mean, normally, yeah, going from height 1 to 53, and just kind of play around with it, have fun with it, see what happens. You're not out too much, just trying to draw a graph. So, and then you can crank the numbers, of course, right? And we did the first one already. If you have a 1-story building, a height of 1 versus the height of the other, what's the willingness to pay? Show what you got. Talk to your buddies. You can get up out of your chair if you want and cross the room. Active learning environment here.
Because 10 times 3 equals 30. Because 3 floors per travel by stairs. And then 27 plus 3 equals 34.
Can the cost be in the horizontal axis?
Less than 3 is.
It basically just says you'd have to pay me to do it, right? So their willingness to pay is nothing, or you pay me. So if you think about a negative, right? So that'll be a good thing to talk about. That's one of the little morsels I want you guys to uncover with this.
Enough for per day.
You also might want to think of at what height would you be indifferent between stairs and elevator? At what height would you be indifferent between stairs and elevator? Put that down as the Russ bonus question here. What'd you get for indifferent between the two?
3.
3. How'd you do it?
I found the 380 minus 300 to get like kind of a regular profit of 80, make that easier for me, and then I just have that 80 minus the cost function on each of them and set them equal to each other.
Okay, so you're indifferent when they cost the same, right? So you can kind of ignore the 300. The total cost would be 300 minus 27 minus h, but really it boils down to this. So setting these two equal to each other will get you to the same spot of 3. All right. So what was the willingness to pay in each case here for 1? Negative. What'd you say? Negative or not?
No, 80
80.
and 230.
80 and 230 for which ones?
A.
For the elevator?
Each one have different willingness to pay?
Well, I want to make sure we're answering the question here. So what is the willingness to pay for the 2 travel modes? So let's just kind of do it together here. At a height of 1, what's your willingness to pay
70.
for the stairs?
70.
70. Did everybody get 70? Jameson? Yes or no?
70?
70? What'd you get?
No, so I don't know how to do it. I know that it's 10, so 80 minus 10 is 7.
80 minus 10. Well, how'd you get that?
Because if you plug 1 in the equation, it's just 10.
Okay, Carlos, why don't you come on up? Let's see what you did.
I guess I did it wrong then.
Well, if you did it wrong, that's good. Because we'll learn from what you did.
If you plug the equation here, you have 10. So I guess the 70 is the willingness to pay of 80 minus the 10.
Yes, 80 minus the 10.
I didn't know that.
So, but you wrote it properly here. This is the cost, right?
Yeah, I thought that the willingness to pay is that we have after paying the labor cost. Is not that?
After the labor, no, that's right. Yeah, but you had the 380 right here,
Yeah.
and labor cost. So revenue minus labor cost gives you 80 left over for now. We've got this travel cost function with the elevator or the stairs.
Oh, okay.
So now what's left over for a building that only has stairs, it would be with a one-story building, it would be 80 minus 10 is 70.
Okay, I didn't do the.
And then for
subtraction.
the other one, what do you got? This one here?
Yeah.
Yeah.
I mean, for elevator which has 1 floor, it's this one. That it's 28.
28, but it's 80 minus the 28. Did you guys get that?
Should be 52.
For the, you can go grab a seat. So what'd you get for the, for 53? What was your, because you're supposed to find out what's your willingness to pay with 53?
At stairs or elevator?
Stairs.
Negative 450.
Oh, like negative.
Negative what?
450.
450. You have to have a number. Negative 450. So you're willing to pay negative 450. Why is that? How do we get, what would that mean?
Somebody would have to pay you.
You'd actually have to be paid to run your building to run your business in that building. So a willingness to pay of negative 450, which means nobody's going to do that. So that just means 0, right? We kind of reached a lower bound. So on that function, at 53 with the stairs, you're just following 380 minus this, so there's your 80 that you guys are doing, minus the stair cost, which was 10 times h. Well, at a 53-story building, that's 530, right? So 80 minus 530 is a negative 450, is the willingness to pay. I'm seeing a couple perplexed looks. Talk to me. Are we all on the same page here?
Yeah.
So then what with the elevator, what did you guys get? With 1, what's your willingness to pay?
52.
With a 1-story with the elevator? There's 52 because you had the 28. I think that's what Carlos had on there, right? So 80 minus 28 was 52.
Yeah.
So 80 minus 28 equals 52. And then willingness to pay with the 53 with an elevator. 80 minus what? What did we get for elevator there? So now we're back to this cost function. We've just got this 27 with an elevator. Your willingness to pay function is the 380 minus the labor minus the 27 minus h. After you put that, it was 27 plus h was the cost function. So what'd you get for that one?
Which one?
For the 53-story building,
It's
willingness to
zero.
pay for 53-story building? 0. So it ended up being 80, so we got the 53, the 27. So with the 53-story building, we've got 80 minus, what's 53 plus 27?
53 plus 27 is 80.
Because this part is 80, so we get 80 minus 80, right? So 80 minus 80 equals 0. So, how's it looking for us to do a 53-story building?
Elevator.
Elevator.
The elevator, and it puts us right at kind of the break even. That's our maximum willingness to pay for that level if it was 53. Okay, and so then my little bonus question, where are we indifferent between the two? If you set the total cost, 300 plus 10h is with the 1-story, 300 plus 27 plus h, these are the total cost. Where are my total costs equal to each other? Solve for h. And a building height of 3 leaves you indifferent between the two.
How do you get the tree?
Just solve for h. So 9h equals 27. The 300s cancel. This was the total cost of the 1-story, total cost of the elevator. We're just setting those equal. I would be indifferent if it cost me the same, no matter what.
Why do you put 10? Okay. Okay.
All right, so now back to the Mackenzie challenge here. Mackenzie, you were the one, I think there was some other people too, but if we were to graph that, 1, 2, 3, ... 50, 53. So our willingness to pay for a 1-story was 70. And then we could map that out at 2 stories or otherwise. At 3 stories, what would be our willingness to pay? We can just kind of crank through some of our willingness to pay for stairs. So at 3 stories, this would be 30. 80 minus 30 equals 50. So we're somewhere at 50. Not totally drawing this to scale here. And then the elevator one at 1 story was 52. So our elevator was 52. at 3 stories they should be equal, so does that actually work out that way? What happens if we throw our 3 into this? 80 minus 27 equals what? 53 minus 3 gets us in there. Look at that. The math world actually works here. All right, so then this willingness to pay function, you know, that I kind of went out of order, but this would basically be going down to 0 at 53. I'm going to kind of cheat, I guess. It's at 53. And then we were at negative 450. At what point is our willingness to pay for stairs 0? How big of a building for stairs? Where does our willingness to pay equal 0?
38.
At 38? At 8, right? So if we set this function equal to 0, that's where our willingness to pay is equal to 0. And so to solve for h, and we can kind of do it in our heads now that we're comfortable with it, but 80 minus 80, so h must be 8, right? So at 8 floors, which would be somewhere over here, now my willingness to pay function for the stairs. So this is for stairs, and this is for the elevator. Oops, sorry. That's kind of an ugly graph. I should have just followed my line out to the 53. Maybe this is the 53 over there. It's not real curved. All right, so we kind of beat that one up, but that's the type of thing you'll hit with some of these and thinking about the trade-offs and, you know, using stairs versus this or other travel expenses. Okay, any last questions there? All right, so to wrap up today, this chapter 13 is kind of more or less a reading comprehension type of chapter. So there's not a lot to cover. So give this a read. So what is spatial distribution in that context? Spatial distribution of employment and residence. What comes to mind for you? Lawson, number between 3 and 8.
7.
1, 2, 3, 4, 5, 6, 7. Kaylin. Spatial distribution, employment and residence.
It's just like employment normally congregates in one place and residence is one place.
Okay, and if it's the distribution, we're talking about one place versus one place, what would be relevant from city to city? Maybe, or town to town. What do people care about as part of their living standards when they work? What would you rather have, a 1-hour commute or a 10-minute commute? 10 minute. So the spatial distribution of employment and residence is wondering how far are we living from where we work? And so the central city concept brings us more towards the center is what we've been talking about. But we still have commute to take into account. And that can be kind of an awful, awful deal. So here is some data from 1960 to 2000. So look at 1960 as the dark. So this is the central city, work in the central city. So live and work. Live and work, live and work. Central city, suburbs, and then the suburbs. So where are we doing over time? What's been the pattern of change Where are we living now? Suburbs. So we've continued to see more and more grow. So here's 2000, the year 2000 versus here, and then Central City versus 1960 in each one. So we can kind of look at the distribution of why do we see these patterns, why do they emerge. So this was 152 metropolitan areas, all with greater than 100,000 residents. "22 kilometers. Let's see. Anybody know how many miles that is? Anybody ever run a 5K?
Yeah.
How many miles is that? Let's just call it 3. So what's 20K?
Be like 70 miles.
4 times 3 is 12. Good price. So 4 times 3 is 12. So around 12 miles is what this median workplace for 25 metropolitan areas. So the question then they look at is compared to the center, is that further or closer from work? So it ends up being 27 from the center for the work. So this is what I mean by this one's kind of, you'll read some stuff in this chapter and they'll talk about the distribution around different places. I don't think Kansas City's on here, we're a little too small. But jobs, how many thousands of jobs? Median workplace, median home place. So you can kind of see in some places San Diego versus other ones that might be closer in Baltimore. Percent of jobs within 5 kilometers of the center. So here's 26 for Boston. 26%, so you're living right in the center, in the core. Pittsburgh ends up being pretty close there, large percent. So here's smaller cities. Now Kansas City might be on this one. Oh, there's Wichita, Kansas. Des Moines. Kansas City, I think we're right in kind of the middle area. So a little bit different distribution. I'm basically just wanting to expose you guys to what will be in the chapter so that we're not digesting, nor will you be tested, of course, on, well, what's the $25 per acre in Chicago? You don't have to memorize stuff like that. So this is more of the reading comprehension stuff. So. All right, so what's the density of jobs? So now we're looking at how many jobs per acre, jobs in the big cities, and we can start to measure density from city to city. Okay, so traffic and population going hand in hand. How many of you have been to LA and been in the traffic there? That's awful. So my brother-in-law just moved away. He worked in downtown LA. So what's with these suburbias and sub-centers? So they're kind of like little cities next to the big city. What do you think would develop in a sub-center? Like, give me an example of an industry that might develop. So we got these sub-centers that might be specialized. What are some industries that you see specialized areas in, maybe? What's that, Bryce? Television, okay.
Power and light district.
Power and light districts, so entertainment districts might be good sub-centers. Like, so power and light is like in downtown Kansas City, but then you might have other entertainment areas that are off of it, right? Because to get there, it's congested, and once it fills up, it's filled up, and so then the sub-centers develop, and they might be specialized. Medical areas might be another thing that develops, and kind of other areas that are specialized as they spill over into other places. Does anybody remember tacit information? That's the weird word, tacit. Who wants to take a stab? What's that?
You feel it, it's hard to explain.
Yeah, you feel it, but it's hard to explain. Yeah, so I love my wife. Well, what does that mean? Define it for me. Well, I can't define that, right? It's just data or information that you have. And so that's what face-to-face time does, and why these centers might develop as they have. So this goes back a ways, 1801. What allows us to get away from the city center? What has changed between 1801 and 1961 in these places? Transportation innovation, right? So horse and buggy versus other factors.
How do you say that?
So increasing the income per household, commuting cost, old housing, all the things we've talked about before with those. And then urban sprawl. So urban sprawl is the idea of wanting to get out, but for some cities they struggle with that because it's harder to get an ambulance or a fire truck out further distances, and so then you have to build another fire station. And each fire station that you build adds to tax dollars, brings up taxes, and now all of a sudden your houses are expensive, and what do we do with the poor people? Where's the low income part of town, right? So that is one of the things that cities grapple with urban sprawl, and housing prices continue to go up. All right, well that wraps it up. We'll call it a little early today. That looks like a good spot.
That's a trick pointer.
The back of the chapter stuff. So no triumph. You guys got the. It's all on the mod 5 for Blackboard. Yeah, 10, 11, and then 13 just has a little bit, but it's just some of the questions. There's no apply questions.
Did you post that in the numbers?
Will I post it?
Sure.
Yeah, can you?
Yeah.
And then do you have that thing that you just did that question on?
So there's homework for
No,
which?
number 2, you just wrote it down?
Yeah.
10. You want
10,
this?
11.
Yeah, can I have that?
Well, you can't have it. You can
Well,
take a
can I
picture of it. Yeah, you can take a picture.
13 doesn't have too much though.